Hi everyone, welcome to srisai online training. In this session of core Python programming, we are going to discuss today the following topics. So Python fundamentals. So we'll continue with Python fundamentals. So under Python fundamentals, today we'll discuss immutability in Python, derived data types. So derived data types, we are going to discuss bytes, byte array, range, none. And we are also going to discuss escape sequence characters and constants. So these are some topics what we are going to discuss today in core Python programming. Before going to the topics, we'll have a small revision what we are discussing in the previous session about Python fundamentals, data types in Python. And we have seen standard or built-in data types like int data type, float data type, complex data type, bool data type, and str data type. Right, so coming to the Python fundamentals. So fundamentals means basics of writing a Python program. Right, so we have 8 basics of writing a Python program. Identifiers, identifying something uniquely in a program like variable name, class name, function name, module name, object name, etc. And for identifiers, we have 6 rules. So reserved words. So reserved words are predefined words with special meaning and special usage in a Python program. So Python supports 30 plus reserved keywords, and reserved keywords should be used only for that purpose. They cannot be used as variable name, class name, or function name. And then coming to data types. So in the last session we have discussed data types. So data means information, type means which type of information we want to accept in a program, store in a program, process in a program, and display the output in a program. So such type of information is decided with data types. So under data types we have standard data types as well as we have derived data types. So coming to the standard data types, we have int, float, complex, bool, str. Right, so under integers it will support positive numbers, negative numbers is 0, and it also supports mathematics number system like decimal number system 0 to 9, binary number system 0, 1, octal number system 0 to 7, and hexadecimal number system 0 to 9, 10 to 15, A to F. So binary numbers are represented with 0, B, octal numbers are represented with 0, O, and hexadecimal numbers are represented with 0x at the beginning of the number. Right, and we have also seen their corresponding number system conversion functions. Okay, like we have seen bin, we have seen oct, we have seen hex functions. So next we have seen float data types. So float data types are nothing but real numbers, numbers with a decimal point. So Python supports standard notation and scientific notation of floating numbers. So in scientific notation of floating numbers, we will have e extended to the power of 10. So complex numbers are imaginary numbers which are represented with a plus bj. So a plus b can be any numeric value, integer or floating. J, so j is square root of -1. And we have also seen bool. So bool accepts only two values, true, false. So T capital, F capital, only first letter capital. And then str. So string is a collection of characters, representation in single quotes, double quotes, triple single quotes, and triple double quotes. So basically single quote is used for single word, double quote is used for multiple words, and triple single quotes and triple double quotes are used for multi-line string, and triple single quotes are also used for writing comments, description of a program. Right, and we have also discussed type casting, so converting one data type value into another data type value, and this is done with int function, float function, complex function, bool function, and str function. Right, so this is what we discussed in the last session. So today we are going to start with immutability in data types. So what is this immutability? We'll try to understand. So coming to immutability, so basically in Python, everything is an object. Every value is an object, and this object belongs to any particular class. So for example, if we take 10, so 10 belongs to class int. Next, if we take something like 5.6, it belongs to class float. So like this, everything is an object in Python. So coming to immutability. So immutability means data cannot be modified, but it can be reassigned to any variable of fundamental data types. So the data which is used, the value which is used in data types, so that is a fixed value. It cannot be modified, but it can be reassigned to any variable. So for example, if we try to change any data value, so if we try to make any changes to the data type variable, then we get a new object for that particular value. Okay, so data type variable value, then we get a new object, value is created. So for example, if we take something like a is equals to 10, print a id of a. Okay, so a is equals to 10, print a id of a. So a will be pointing to a memory location where 10 is the value. Now if we say a is equals to a plus 10, so 10 plus 10, 20. So we'll get a new value, and that new value will be 20, and this 20 will have a new memory location. So IDs are not same for previous a and new a, modified value of a. So let us try to demonstrate this with a small program, Immutable Values Dot Py. So first, at the beginning of the program, take a new page, program to demo immutable values. Right, so we'll put comment for the remaining cases. Right, so first we'll take a is equals to 10, print a id of a. So 10 is a unique memory location to which a is pointing to. Okay, right, so after that we'll say a is equals to 10 plus 10, 20. Now a will be pointing to another new value object which is 20. So if you say id of a, previous id and this id will not be same. So save this program, come to the command prompt, go to your working directory where you have saved the program and run the program. So py immutable values dot py. Right, so initial value is 10, 10 plus 10, 20. This is the new value. And if we see the location of 10 and location of 20, both are not same. So this is 144, this is 464. So this is immutability, means values cannot be modified. If we try to modify them, we'll get a new value with new ID, new address or new reference in the memory. Right, so next let us understand few more things about the immutability. So basically in Python, any data type new value object, okay, any data type new value object is required. It is not created immediately, but what Python will do is Python will check for the existing object and reuse that in the program. And this is called as memory utilization and improved performance of the Python program. It's very simple here. For example, if I say x is equals to 100, print x id of x. Similarly, if I say y is equals to 100, so y is equals to 100, we will not get a new object. It will reuse the existing object which is pointed by 100. So when we say print y and then id of y, so both the IDs will be same. So let us try to demonstrate this in the same program, Immutable Values Dot Py. Right. So if you see here, x is equals to 100, print x id of x, y is equals to 100, it will reuse the previous value with the same id. So print y id of y, both will be same. So come to the command prompt and run. So x 100, y is also 100. So x is pointing to this location whose value is 100, and y is also pointing to the same location 3728 whose value is 100. So it is reusing the existing value object location. Right. So next, in immutability, okay, right. So what is the use of immutability actually? So the above approach of using same value for multiple variables of single reference, okay, is, so why we are using this approach? If any variable changes the value, then it is affected to the other variables also. So if x changes the value, then it will be reflected to y. So for this reason, immutability concept is introduced. So if x changes to 100, okay, so 100 plus 10. So example, if x is equals to x plus 10, so which becomes 110. Okay, so now x refers or points to 110. So this is a new object. Okay, this is a new object, but y refers or points to same old object, which is 100, which is same old object 100. So that is the reason why immutability concept is introduced. So when x changes the value, it will get a new reference of 110 created in the memory, and y will use the same old object. And basically, if you want to check IDs of two particular objects, then we use is operator. So for this, we are going to use is operator. Okay, so is operator is used to check the reference of two variables. For example, a is equals to 10 and b is equals to 10. So here we can say a is b. It will return true or false. So let us try to check this. Okay, so we'll use the same program, is operator. Right, so it goes like this. A is equals to 10. So a will be pointing to a value in memory which is 10. B is equals to 10. So B will also point to the same value which is used by A. So print A is B. So both are pointing to the same memory reference or location, true. If true, A is B, so we are going to print A and B have same reference. Else A and B have different reference. Right, so save this, come to the command prompt. Right, so true, A and B have same reference. Right, so for example, if we take something like B is equals to 20. Now B is pointing to another location whose value is 20, and A is pointing to a location or reference or address whose value is 10. So save this. A is B, false. If A is B, false. It will come to the else part. A and B have different reference. So here we'll also say print A and print B. Okay, or to be more specific, we'll also say ID of A, memory address of A, or reference of A. So save this, come to the command prompt and run. So A and B have different references. False. So A is pointing to 1600 reference and B is pointing to 1920 reference. So this is how immutability concept is introduced in Python programming. So every value is an object. So variable will be pointing to that particular object address. So that is what we call it as reference location. So any doubts still here, guys? So now let us try to work with some derived data types in Python. So derived data types in Python. So what are derived data types? So derived data types means these data types are formed from standard data types. These data types are formed from standard data types. Okay, so what are derived data types? So they are, so we have bytes, bytes array, byte array. Okay, next bytes array or byte array. Next we have something like range, none, we have set, frozenset, we have tuple, we have list, we have dictionary, etc. Okay, right. So as of now we are going to discuss in Python fundamentals bytes, bytes array, range, none. So these are the topics what we are going to discuss in Python fundamentals. Okay, and next coming to set, frozenset, tuple, list, dictionary. Now for this we have separate chapters. Okay, so in separate chapters, so we have separate chapters for this. As of now in Python fundamentals we are going to discuss these derived data types. So already we have seen int, float, complex, bool, and then we have also seen how to work with str. So we have seen 5 standard data types. Okay, so we have 5 standard data types. They are int, float, complex, bool, boolean value, and then str, string. Now coming to the 6th data type, which is a derived data type. So let us try to understand 6th data type, which is bytes data type. So what is bytes data type? So bytes data type represent collection of byte numbers. Okay, and these byte numbers are 0 to 255 values. So it is collection of multiple byte numbers, and these values are ranging from 0 to 255. Okay, so it is like an array, collection of same type of values. So for example, if we take a list, so list is represented in square brackets. So for list we have a separate topic, separate chapter, but I'm going to use list of values and convert that into byte values. So let us take a list of values 11, 22, 33, 44, 55 and store that in A. So A is nothing but a list of values. So we'll convert this A into bytes. How? bytes of A. So here bytes function converts list to bytes type. So now B will become bytes. So if we say print type of B, so we'll get class bytes. It is of type class bytes. So bytes is nothing but collection of values, and these values will be ranging from 0 to 255, multiple values. That's it. And in bytes data type values, collection of values, we have indexes. So these indexes are 0, 1, 2, 3, 4, so on till n minus 1, first to last. And we can also have negative indexes, last to first, minus 1 to minus n. So it's very simple here. So this is 0, 1, 2, 3, 4, n minus 1. And this is minus 1, minus 2, minus 3, minus 4, and minus 5. So how to access them? Okay. So how to access the values of, okay, access values of bytes data type. So it's very simple. B of 0, B of 1, B of 2, B of 3, B of 4. Similarly, from last to first, B of minus 1, minus 2, minus 3, minus 4, and minus 5. So let us try to demonstrate this with a small program. Datatype example 6.py. Right. So program to work with bytes data type. So take a comment at the beginning of the program. So initially we are taking a list A, 11, 22, 33, 44, and 55. So this list we are going to convert into bytes. How? Using bytes function. So bytes of A converts list A into bytes and stores that in B. So print type of B. Okay, we'll execute till here. So let us put a comment for the remaining cases. Multi-line comment, type of B, and we'll also print B. So save this, come to the command prompt, run. So data type example 6. Right, so data type is class bytes, and when we try to print bytes collection of values, we are getting some address here. Okay, right. So how to access the values of bytes using indexes? Okay, so I'll write here using indexes. B of 0, B of 1, 2, 3, 4, first to last. Similarly, B of minus 1, minus 2, minus 3, minus 4, minus 5, last to first. Right, so save this and run. So 11 to 55 and 55 to 11. 1, 2, 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4, and minus 5. Right, now we can also access bytes data type values using array, using loop. Okay, for loop. For example, for loop variable I in B. What is B? Bytes data type values, which is collection of byte values. Okay, I in B, print I. So each value of B, I'll write here, each value of B, which is bytes, is assigned to loop variable I. Okay, and it will print I. So first 11 is assigned to I, print 11. Next 22 is assigned to I, print 22. Next 33, print 44, print 55, print. No values, it will come out of the loop. Okay, so no values, it comes out of loop. So this is how for loop is going to work for us in Python programming on collection of values like bytes. Okay, right. So use the same logic in the program for I in B. Okay, I in B, loop variable in bytes B, print I. So save this, come to the command prompt and simply run. So 11, 22, 33, 44, 50 using for loop. Next, we can have values in bytes. Okay, 0 to 255, less than 256, which is 255. Okay, and this bytes values are immutable. Okay, we can't change them. If you try to change them, we'll get an error. Okay, so byte values cannot be modified, but we can reassign new data. Okay, so this is called as immutability. Immutable. So bytes is immutable. It cannot be modified, but we can reassign the new data, but we can't modify the existing data. So let us try to demonstrate that. Okay, right. So once we give bytes values, it cannot be modified, but if you want, we have to give new data all at a time. Okay, so let us try to do this. It's very simple here. So first one will take values which are above 255. For example, a is equals to, we are taking values 11, 111, 222, 333, 44, 555. So these are list of values. Okay, list of values. So this list of values we are converting into bytes B. So convert bytes of list into B. So here we'll get the error because we have 333, 444, 555 out of range. So save this, come to the command prompt, run. So if you see here, we got error here. So bytes must be in the range of 0 to 256, means 255. 256 is not accepted because we have 0. Right, so now let us take a list 111, 222, 33, 44, 55. So all these byte values are within 0 to 255, less than 256. Now no error. Okay, no error, and print with for loop. For I is equals to B, print I. So save this and run. So 111, 222, 33, 44, 55. Right. And next we'll try to change the values of byte array. Okay. For example, B of 0 is equals to 200. So here we are changing the value from 111 to 200. Okay. And print B of 0. Save this, first value. So we'll get a type error. Bytes object does not support assignment. It is immutable. Okay, but we can reassign with new list of values, but not individual value. Right, comment it. B of -1, last value. I'm trying to change it to 50 and print 50. Here also we'll get the type error. So it cannot be supported for new assignments. So bytes is immutable collection of values. Once we assign them, we cannot modify them, but we can reassign new set of values. So reassign new set of values means it's very simple. I'll take something like a is equals to 1, 2, 3, 4, 5. It is a list of values. List of values. Now this list of values will convert into B, bytes of A. So list will be converted into bytes B. Now we are reassigning. This is okay. Reassigning is okay, but not modifying individual values. But no modification of individual values. Individual values. Now if you say here for loop, we'll get the new values in the bytes B. So save this and run. These are the new values in the bytes. And if you try to change any individual value, we'll get an error. It's very simple. B of 0, I'll change it to 11. Print B of 0. We'll get a error. Save this, run. So B of 0, 11. Bytes object values does not support individual assignments. So this is what is about bytes. Collection of byte values. Okay, and these values will range from 0 to 255. And bytes function is used to convert list of values into collection of byte values, which is bytes. So this is how we are supposed to work with bytes, which is a derived data type in Python. So now let us go for another derived data type, which is byte array. Derived data type. So we have seen bytes, byte array, both are same. So it is same as that of bytes array. However, data can be modified here. So data can be modified individually with indexes. So technically it is called as mutable object, whereas bytes is immutable object. Okay, so it is done with indexes. Okay, so it's very simple here. So let us take one list values 11, 22, 33, 44, 5. A list. So we'll convert this A list into byte array using byte array function. So byte array function will convert that into byte array B. So byte array function converts list to, so list of values to byte array type. So here same thing, we have indexes to access the values of a byte array. So 0, 1, 2, 3, 4, so on, n minus 1, first to last, it is in forward direction. Similarly in backward direction, last to first, we have minus 1, minus 2, minus 3, minus 4, so on. So example goes like this here. B of 0, B of 1, B of 2, B of 3, B of 4. So this is B of 1, 0, B of 1, B of 2, B of 3, B of 4. Next, B of minus 1, minus 2, minus 3, minus 4, minus 5. So let us try to demonstrate this with a small program. Data type example 7. So take a new page. So first we'll write the comments. Right. So let us put a comment for the remaining cases. Program to work with byte array data types. So we are taking A, which is list of values 11, 22, 33, 44, and 55. So we'll convert this list of values into byte array. So byte array of A and store that in B. So print type of B and B. Right. So save this program in your working directory. Now come to the command prompt and then run data type example 7. Right. So we'll put proper comments here. Save it. So the type is byte array. Previously it is bytes class. Now it is byte array class. And then it is printing the address of that byte array in memory. Now how to access them? Using indexes. Using indexes. Access the values. So print b of 0, b of 1, b of 2, b of 3, b of 4. First to last. Print b of -1, -2, -3, -4, -5. Last to first. Save it and run. So 11 to 55, 55 to 11. First to last and last to first. So 0 to n-1, forward direction, -1 to -n, backward direction. Right, now we can use for loop to access the byte array values. So it's very simple here. For I in B. Okay. So each time byte array B. So byte array B values are assigned to I. I is a loop variable. So after assigning I value to the I, print I. Body of the loop is executed. That's it. So first 11 is assigned to I, print I. Next 22 is assigned to I, print I. 33, print. 44, print. 55, print. So after that we don't have any values. Okay. So no values, then come out of loop. Right. So let us try to execute this in the program. So same like bytes only. So for I is equals to B, print I. So save this and run. So again it has printed 11, 22, 33, 44, 55 using for loop. Next. Now the range of values which are supported by byte array is 0 to less than 256. Otherwise we'll get a value error. Okay. And byte array values can be modified or changed individually, and this is done using indexes individually. Whereas in bytes it is not modified. So let us check this. Right. So if we see here, first we'll take list of values 111, 222 out of range, 333, 445, 555. These are list of values. So these list of values will convert into byte array using byte array function and store that in B. We'll get an error and print with for loop. For I is equals to B, I in B, print I. So save this and run. So byte array of A, range 0 to 256, which is 255. Less than 256, which is 255. Last value is not included. So now let us take 111, 222, 33, 44, 55. Now we will get accepted values. 111, 222, 33, 44, 55. Right. So this is how we are supposed to work with range of values 0 to 255. Next, values can be modified here. It's very simple here. B of 0, first value 255. B of -1, last value 155. Print with for loop. For I in B, print I. So save this and run. So first value 255, 222, 33, 44. Last value is changed to 155. So this is how we can modify the values of byte array. whereas in bytes it is not modified. So one important note point here. Now list, tuple, set, frozenset, dictionary. We have separate data types, separate chapters. These are derived data types. We have separate chapters for them. So this is how we are supposed to work with byte array data type, which is collection of byte values, and it comes under derived data type. It is mutable object. Next, let us work with range data type. So range data type, it is also a derived data type. Okay, so what is the use of this range data type? It provides sequence of numbers, only numbers, and range data type values are not modified. It is immutable object, same like bytes, which is immutable object. So how to get range of values? Now for this we use range function to get range of values. It's very simple here. Example, range of 10. We are going to get a range of values from 0 to 9. So store that in R. So given number is not included. So 0 to 9, 0 to 9. Given number is not included. And we can print this range of values using for loop. So for I is equals to, for I in R, print I. Okay, so each value from R is nothing but range of values, okay, is assigned to loop variable I, and then print I. So first initially 0 is assigned to I, print I. 1 is assigned to I, print I. Similarly 2, 3, 4, 5, 6, 7, 8, 9. Print 2, 3, 4, 5, 6, 7, 8, 9. No numbers in the range of values come out of the loop. Okay. So when no values in range are, then come out of loop. So it will come out of loop. Right. So let us try to demonstrate this with a data type example 8.py. So take a new page. First write the comments, program to work with range data type with range function. Right. So initially we'll take range of values basically from 0. So it goes like this. Range of 10, it will generate a values from 0 to 9. Store that in R. Print R. Print type of R, and then print all the values using for loop. For I in R, print I. So save this, come to the command prompt, and then run data type example 8. So range 0 to 10. So when we print R, we'll get this range 0 to 10, and these are data type, range of type class, and then this is what is, okay, values using for loop 0 to 9. So next we can also use range of values with beginning value and ending value. For example, range 10 to 20, 10 comma 20. So 10 is beginning value, 20 is ending value, 20 value is not included. So when we try to print with for loop, so for I in R colon print I. So this is single line for loop. Okay, so it will print all the values from 10 to 19. Right. So take the example 2. So range 10, 20, store that in R, So for I in R, print I. So save this and run. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 is not included. So beginning value, ending value. Similarly, we can also take a step value. So step value is nothing but increment value. So it's very simple. Range, beginning value 10, ending value 20, ending value is not included, comma. Step value is 2. So 10, 12, 14, 16, 18, 20 is not included. So 2 is the increment value. So default increment is 1. So generally we can also have increment positive or negative. So negative means it will come negative, it will minus, positive means it will do plus. So we can also print this using for loop. Right, so come to the program. Right, so let us take the same example. Range 10, 20, 2. So store that in R. So for I in R, print I. So this is single line for loop. Instead of taking print I in the next line, we are taking it in the same line with a space. So save it and run. So 10, 12, 14, 16, 18, 20 is not included. Right, so similarly, now we can also access range of values with indexes. So forward indexes are 0 to n minus 1. It will print from first to last. And backward indexes last to first are minus 1 to minus n. So same like bytes, byte array. So R of 0, 1, 2, 3, 4, 5. And similarly, we can also have R of minus 1, minus 2, minus 3, minus 4, and minus 5. If we take R of 20, we'll get a error, index out of range. Right. So let us try to demonstrate this. So we'll take here values like, yeah, range 10, 20. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 20 is not included. So print R of 0, R of 1. R of minus 1, minus 2. So first two values, last two values. So save this and run. So first two values are 10, 11, and last two values are 19, 18. Right, so now let us try to access out of range. R of 20 will get an error. So index out of range, R of 20. Similarly, we'll take something like R of 0 is equals to 100. So here range values are immutable once it is generated. So we'll get an error. The reason is immutable object. So range values are immutable object. Range values are immutable object. So save this and run. So okay, so let us put comment for R of 20, save and run. So range object does not support. Okay, so range object does not support individual values assignment. So this is how we are supposed to work with, okay, range of values. Okay, so coming to some one technical points here. If you want to store images, audio, video files, so for that we use bytes array data type. So this is highly advisable. Images, audio, video, we contains binary data, so that is best suitable for byte array data types. And in Python we don't have long data type, it is removed from Python 3. So we use int data type only to store big values or large integer values. and we don't have char data type also. So in str only we store single characters using single quotes or double quotes. And int, float, complex, bool, str. Bytes, range, tuple, frozen set are immutable objects. Data cannot be modified. So range, tuple, frozen set we'll see later. And coming to byte array, list, set, dictionary are mutable. Data can be modified. So we'll discuss list, set, dictionary in respective chapters. They are mutable. Data can be modified. So this is how we are supposed to work with range data type, which is a derived data type in Python. Next, let us try to work with none data type. So none data type also comes under derived data type. So what is none? So none means nothing or no value. So in Java it is called as null, nothing or no value. So very small example for that as of now. Later we'll discuss many examples for this. So I'm taking one Python function, definition, m1 function, colon, a is equals to 10. So this is the definition of Python function m1. And I'm calling this function using print m1 function. So when you say print m1 function, it will go to the m1 function and it will assign a value to 10. And this function is not returning anything. So it will return none. And here it will print none. So let us try to demonstrate this with a small program. So to program to work with none data types. Okay. So instead of a is equals to 10 here, we'll say print hello for our easy understanding. Right. So at the beginning of the program, take the command program to work with none data type. So define m1 function. Its block of code or body is print hello. Call m1 function. Okay, we'll execute till here. Save this in our working directory. Come to the command prompt and run data type example 9. So when you call m1 function, it is printing, it will go to the m1 function from line 6 to line 3 and it will print hello. Now this m1 function, it is not returning any value. So it will return none if you say print m1. So it will go to the m1 function, print hello. It is not returning anything, it will print none. So m1 function does not return any value. Okay, so does not return anything. So it will return or it will print none. So let us put this comment hash. So save this, run. So when you say print m1, it will print hello. It is not returning anything, so print none. Nothing is returned by the m1 function. So this is how we are supposed to work with none data type. And this none data type is nothing or no value. And we are going to discuss more about none with different topics. This is just the basic examples. And similarly, list, tuple, set, frozen set, we have separate chapters. At that time we'll discuss different examples. So next, let us try to work with escape sequence characters. So these characters, they are combination of two characters. So first character is a backslash and second character is a regular character. So what is the use of these special characters? They have special meaning and special usage in program. For example, new line character backslash n, it takes the cursor to the next line. So for example, print Sai new line, Ram new line, Kumar new line. So Sai, Ram, Ali, they will come in the new lines. So similarly we have tab space. So tab space, it will take 8 spaces at a time. So \t. So Sai 8 spaces, Ram 8 spaces, Kumar \t. Next we have \b. It is called as backspace. It will take one space back. Similarly, we have carriage return \r. It will take the cursor to the beginning of the program. Next, we have form feed. Okay, \f. It will take the cursor to the next page. This is mainly used for printing purpose in old style. Vertical tab \v and \v. Hello \v world. So vertical tab means from that particular place it will come directly to the next line. Okay, so form feed and vertical tab, these are outdated. These are not supported in new compilers. And then if you want to have single quote, \single quote. If you want to have double quotes, \double quote. If you want to have backslash in our message or string, then it is double backslash. So let us try to demonstrate this with a small program. So program to work with escape sequence characters. So first, Sai, new line, Ram, new line, Kumar, string. So save this in your working directory, come to the command prompt and then run escape sequence chars.py. So Sai, Ram, Kumar in 3 new lines. So similarly, we'll take tab spaces. So Sai tab space, Ram tab space, Kumar. We'll get 8 spaces. So Sai tab space, Ram tab space and Kumar. Sometimes it will take 5 spaces also. 1, 2, 3, 4, 5, and these spaces are counted from the beginning. 6, 7, 8. After that 1, 2, 3, 4, 5, 6, 7, 8. After Kumar, if we take a tab space, we'll get only 3 spaces because these tab spaces are counted from the beginning. So Sai, Ram, Kumar, Ajay. Now we'll get Ajay after 3 spaces. 1, 2, 3. So tab spaces are counted from the beginning. Next, backspace, 1 space back. So print hello world, 2 backspaces ks. So 2 backspaces means it will come to DL and from there it will print ks. So it will become works. Save this. Hello works. Similarly, carriage return. So Jack, carriage return B. So carriage return will take the cursor to the beginning. Beginning means J. So from J it will print B. It will become back. Run. So Jack, carriage return B, back. Next, form feed and vertical tab. It is not going to work for us. We'll get a special character. Hello form feed world. Hello vertical tab world. So save this, run. So form feed, we got a special character. Similarly for vertical tab. So next, if you want to have single quote, double quote and backslash in your string, then how it is possible? So hello \single quote, hello \double quote, hello \backslash. Save this and run. So single quote inside a string, double quote inside a string, backslash inside a string. It is possible through one backslash at the beginning. So this is how we are supposed to work with escape sequence characters. Combination of 2 characters backslash with a regular character. It provides special meaning and special usage in a program. And then finally, we have the concept of constants. So constants means fixed values, or technically it is called as literals. And this concept is not available in Python. However, if you want to have some constants, we give constants variables in block letters just for representation purpose. Example, pi 3.14, max 100, minimum 55. So this is just a notation or standard to have constants in block letters for variable names, but value can be modified. Example, we can change pi value as something like 3.1456. So this will be the new value, new assigned value. Okay, but this is just a notation in Python. So this is what is all about today's session, guys. So in today's session, we have discussed how to work with Python fundamentals, immutability in Python, derived data types, bytes, byte array, range, none, escape sequence characters, and constants. So that is what is all about today's session in core Python programming. So thank you all of you for watching, listening to this session. Have a nice day.